To evaluate this sigma, first you're going to expand. So it's going to be 2 into 1 actually. Let me erase this part. So it's going to be 2 into 1 minus 1 plus 2 into 2 minus 1 plus 2 into 3 minus 1. We only need the first 3 terms and also our last term. So our last term is going to be 2 into 20. The position of our last term is 20 minus 1. So 2 into 1 minus 1, we're going to get 1 plus 2 into 2 minus 1, we're going to get 3 plus 5. 2 into 3 minus 1, 2 into 3 is 6. 6 minus 1, we're going to get 5 plus all the way up to 2 into 20 is 40. 40 minus 1, we're going to get 39. Then our next thing is to evaluate what kind of a series is this. Is it an arithmetic series or a geometric series? So let us check the difference first. 3 minus 1, we're going to get 2. 5 minus 3, we're going to get 2. Then that means this series has a common difference. There's a common difference of 2. And our first term is 1. Then this is the arithmetic series. So in arithmetic series, if the last term is known, you can use this formula to determine the sum of the series. It's a plus our last term, and n is the position of how many terms are we adding in this series. We are adding 20 terms for this series, so it's gonna be 20 divided by 2 into our first term is 1 plus our last term, which is 39. If you punch this on a calculator, you're gonna get, so it's gonna be 20 divided by 2 into 1 plus 39. So you're gonna get 400. So our value for this series is gonna be 400. That's how you evaluate the sigma. Let us try another problem. By the way, feel free to pause the video and try this problem. So if you are given a sigma of a constant value, and when the value, so our last problem, our sigma was starting at n is equals to 1, but now our sigma started n is equals to 2. We need to first know how many terms are we adding in this series. So to get how many terms are we adding in this series, we're gonna say n is equals to this value. This tells us that there are 10 terms in this series. However, minus 2 plus 1. This is how you get how many terms are we adding in this series. It's gonna be 10 minus 2 plus 1. You're adding 9 terms for this series. Then for a sigma of a constant value, if it's 5, 4, 3, 2, 1, for a sigma of the constant value, it's gonna be equals to 5. You're gonna take this value times the number of terms in a series. There are 9 terms in this series, so it's gonna be 5 times 9. 5 times 9 is 45. So that's how you get the value of the series. Let us try this one. Feel free to pause the video and try this one. So in this one, our summation starts from n is equal to 0. So it's gonna be 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2. We only need the first 3 terms of the series. So the reason behind why we need the first 3 terms of the series is to determine what kind of a series is this. Is it an arithmetic series or a geometric series? So we can go all the way up to up to 10, 2 to the power of 10, which is our last step, 10. 2 to the power of 0 is 1, 2 to the power of 1 is 2, plus 2 to the power of 2, 2 to the power of 2 is 4, plus all the way up to 2 to the power of 10. So I'm not gonna get the value of 2 to the power of 10. Is it an arithmetic series or geometric series? So to check if the series is arithmetic, is it an arithmetic or geometric? So let us first check if the series is geometric. To check if the series is geometric, you simply gonna check the ratio between any two consecutive terms. 2 divided by 1, you're gonna get 2. And 4 divided by 2, you're gonna get 2. Then you can clearly see a ratio between any two consecutive terms is 2. So our ratio is 2 and our first term is 1. But we need to know how many terms are we adding in this series, because our series is not starting from 1, starting from n is equal to 0. So get how many terms you are adding in this series, you're gonna say this number minus this number, which is 0, and we're gonna add that number by 1. So we're gonna get 10. 10 minus 0 plus 1, we're gonna get 11. So 11 is the number of terms for our series. So since this series is an arithmetic geometric series, we can use this formula. So we can use this formula. Can use this formula. Sn is equal to it's a into r to the power of n minus 1 divided by r minus 1. N is the number of our terms in a series. So we have 10 terms in our series. We have 11 terms in our series, so to speak. A is our first term in our series, so it's 1, into r is our ratio of the series is 2 to the power of 11 minus 1 all over 2 minus 1. And if you punch this on a calculator, we're gonna get, let me punch this on my calculator. So we're gonna get 2 to the power of 11 minus 1 all over 2 minus 1. And the value of the series is going to be 2047. So it's gonna be 2047. Now this is the last example for this video. Feel free to pause the video and try this one. Write this series in sigma notation. So it's gonna be, if you write this series in sigma notation, always you need to find the general equation of this series. The general equation, not of the series, but of since this is the geometric series, we need to find the general equation of this geometric sequence. So it's gonna be Tn is equal to a r to the power of n minus 1. A is our first term, which is half into our ratio. The ratio for this sequence is gonna be half. 1 all over 4 divided by half, and you're gonna get half. So our ratio for this sequence is half, n minus 1. This is our general equation for this series. Now, to write this in sigma notation, you're simply gonna write sigma, and our series starts from n is equal to 1, and we need to count how many terms are we adding in this series. So it's 1, 2, 3, 4. We are adding 4 terms, and you're gonna put 4 here, and then you're gonna say half into half all to the power of n minus 1. That's how you write the series in sigma notation. Thanks again for watching this video. Have a nice day.